All right, welcome back. Now we have done quite a few things in the last video to set up our interpolation mechanism. We have a enum in item.h called item type. We're going to use that very shortly. We've also created a struct in shooter character called f_interp_location, and we have an array of those which we're initializing with a function that we call in begin play, sticking all of these scene components into f_interp_location structs and shoving them into an interp_locations array. So the idea is that at any given point in time, this array will hold information regarding how many items are interping to our interp_locations. Each one has a struct holding the scene component and also the number of items interping to it. Now we need a function that will return a interp_location index, an index that will tell us which of the interp_locations in this array are the one we want. Now, which one do we want? Well, if there are multiple items interping to different scene components, we want to pick the one that has the least amount of items interping to it, or one of the ones that has 0 items interping to it. So we're going to use that integer in the interp_location struct for that. So we're going to create a function called getInterp_location_index to get the index of the interp_location that has the least amount of items interping to it at any given point in time. So let's go up to our protected section and create a function that returns an int32 called getInterp_location_index. Now let's go ahead and create a function body for this. Okay, so this is going to only be concerned with our interp_locations 1 through 6. Remember, the 0th element in our interp_locations array is our weapon interp_location. So really, this is going to be for those 6 item interp_locations. Those are where our ammo item pickups are going to interp to. Now, in order to get the index in that array for the interp_location that has the lowest number of items interping to it, we're going to need a local variable to keep track of that. I'm going to create an int32 called lowest index, and I'm going to set it equal to 1. Now, I'm going to have a int32 called lowest count, and this will be the number of items in the interp_location with the lowest number of items interping to it. Now, so far we don't know which one has the lowest amount. So I'm going to set this lowest count to a very high number. In fact, why not just set it to the highest number possible for an int32? And that is int max. This is a macro that holds the maximum value that an int32 can hold. Now here's what we're going to do. We're going to loop, we're going to use a for loop. We're going to start it off with int32 I equals 1. And we're going to loop through the number of items in interp_location. So we're going to say I is less than interp_locations.num. So we're looping from 1 to 6 basically. And we'll have I++. And it looks like I need a T there. There we go. Fix that typo. So what are we going to do? We're going to loop from 1 to 6 in our interp_locations array. And we're going to check to see if the item count at that index is lower than lowest count. Now, the first one obviously will be because lowest count is the highest number possible. But we're going to keep looping through and see if the next one has a lower count than the one before it. And we're going to set that equal to the lowest index if that's the case. So by the end of this, we will have the index with the lowest number of items interping to it. So we're going to do that by saying if interp_locations at I, this gets us an f_interp_location struct, and from that we can get its item count. Now if that item count is less than lowest count, which the first one definitely will be, then we're going to say lowest index equals I. And we're also going to say lowest count is equal to interp_locations at I.item count. So lowest count only starts off at a really big number. As soon as we check the first element in interp locations, we're setting lowest count equal to the count for that particular item. Now, if there's a lot of items interping to this first element, well, then the next iteration of the for loop will check the next struct to see its item count. And if it's lower, well, now we're going to set our lowest index to that one. And we'll keep going until we get to the end. The result is, by the end of this, lowest index will give us the index of the struct that has the lowest item count. So at the end, we're going to simply return lowest index. So now we have a function that will return us the index of the struct in interp locations that has the lowest item count. Now, if they all have 0, then it'll give us the first one. Now, for any given item, when it's interping, it's going to be interping to a location in our interp array. So it needs to know which index it's interping to. So let's go to item.h and add an int32 for the interp location index. We'll do this at the bottom of the private section. This will be an int32. I'm going to call this interp loc index. Now, this could be a U property. We'll make it visible anywhere. Blueprint read only. And I'll just give it the category item properties and the meta specifier. And we'll give this a comment, and we'll say, index of the interp location this item is interping to. Now we'll start this off with a default value of 0 in item.cpp. So go to the item.cpp constructor and initialize this to 0. Now we need to set this as soon as start item curve gets called. So let's go to start item curve. And as soon as we start the item curve, we need to set interp loc index. And how are we going to set it? Well, we can simply get our character and call get interp location index. And this will give us the index for the interp location with the lowest number of items interping to it. Now it looks like it's inaccessible because we didn't make it public. We made it protected, I remember. So let's go back, and get interp location index should be stuck into the public section. So let's put that all the way down here at our public section. And why don't we give this a comment and say returns the index in interp locations array with the lowest item count. Now in item.cpp, we can call it just fine. So let's give this a comment here and say get array index in interp locations with the lowest item count. Now, if we're going to set the item to have this interp location index and designate that location for the interp location for this item, well, then we need to get that array element and get that struct and add one to its item count. That way, the item count for that particular interp location is accurate, since we now have an item interping to it. So let's go ahead and create a function on shooterCharacter.h that we can call to increment that interp location item count. It's going to be public, so we can call it from the item class. This will be void, and we're going to call this increment interp loc item count. Now this is going to take an int32 for the index and also an int32 for the amount. So let's go ahead and implement this. So down here at the bottom of shooter characters CPP file, I'm adding a function body, and here's what we're going to do. First, I'm going to check to see if amount is less than -1, and also if we're incrementing amount by anything other than 1, that's not good either. We only want to increment it by 1. So if amount is greater than 1, if either of those are true, I'm going to simply return. Otherwise, we can increment the item count for the particular interp location. So we're going to say if interp locations.num is greater than or equal to index. That way we're not trying to access an array element that isn't there. And by the way, num is a function, so it needs parentheses. Then we're going to say interp locations at this index. That's a struct. We're going to get its item count, and we're going to add amount to that. So if we call this and we pass in an index and we pass in 1, then we'll add 1 to the interp location's item count at this index. That's what we need to do here in item.cpp as soon as we get the interp location index. So right after we get interp location index, what we need to do is increment the item count at that index. So we're going to get the character and call increment interp loc item count, and we're going to use interp loc index for the index and 1 for the amount. And we'll give this a comment and say add 1 to the item count for this interp location struct. Now we also need to update this as soon as we're done interping, and that's going to be in the items finish interping function. So let's go to finish interping. And here in finish interping, right after we check to see if character is valid, we can go ahead and subtract 1 from increment interp location item count. So we're going to say character increment interp loc item count. We're going to use interp loc index and -1 for the amount. And so that way we can subtract 1. So let's give this a comment and say subtract 1 from the item count of the interp location struct. Okay, so this takes care of designating an integer for where we should interpolate to. But all that does is set an integer on item.cpp. The real core of this mechanic is in start item curve, where we get our interpolation location. That's the target location for our interpolation. So now we have a interp location index, and this is going to be the index in the character's interp locations array that we want to interp to. So how do we actually interp to it? Well, the key lies in our interp function. So remember, in tick we have this item interp function. If we go ahead and go to that function, then here we'll see that we're getting a camera interp location. This is a vector that we're getting from the character. Now, instead of just simply getting the interp location that we hard-coded for the camera, we want to check our item type using that enum we created and find the correct interp location that we should interpolate to. So let's create a function to do this. Let's go to item.h and create a protected function, and I'm going to call this function getInterpLocation, and it should return an f vector. So getInterpLocation, and I'll give this a comment, and we'll say getInterpLocation based on the item type. Let's give this a function body. And since we're going to need the character, we're going to first check to see if character is null. If character is null, then we're simply going to return a value of an empty f vector. We'll just fill it with zeros, actually. Now, this is going to give us a different location depending on whether we're an ammo or a weapon item type. So let's switch on our item type variable. And we're going to have two cases. We're going to have the case where it's an E item type ammo, and we'll have a break. And then we'll have a case where it's an E item type weapon. And this will also have a break. So what are we going to return when we are an ammo item type? Well, the character has a getInterpLocation function. Remember, in shooterCharacter.h, we created a function that returns an interpLocation struct based on an index, and that's a public function. So we can call that. We're going to return character getInterpLocation. But what is the interp location? Well, we have our interp location index. Now, this just returns us a struct. It returns us an f_interp location struct. But we want a location to interp to, and that exists on our scene component in our struct. So the scene component has a location, and we get that using get component location. That's what we do if we are an ammo type. But if we're a weapon type, we simply want the index of 0. So we're going to say character get interp location at 0. That's the weapon interp location. And then that will give us the location stored in that scene component, which is the weapon scene component. So when our switch statement reaches one of these cases, we return out of the function and return the location at interp location index. So now we have a function to get that f vector, so we don't have to get the vector that we previously hard-coded for our interp target location. So let's go back into item interp, and as we scroll down, we'll see that we have our camera interp location. And instead of calling characters get camera interp location, we're now going to call our new function that we called get interp location. Let's go ahead and call that instead. So camera interp location will be initialized using get interp location. And in fact, character no longer needs get interp location. So we can actually go to shooter character, and here it is, get camera interp location. We no longer need this. So I'm going to comment it out and add a comment and say no longer needed. A item has get interp location. And I'm going to go to the function definition as well in shooterCharacter.cpp and search for it. And I'm going to comment this out, and I'm going to say no longer needed. A item has get interp location. All right, so let's go ahead and compile this. We've just done a whole lot of things, and we're going to want to see how this works. Now, just to recap, we have our item interp function here in the item.cpp file, which is called every frame. And in this function, we set our camera interp location local variable to get interp location. Before we were calling shooter characters get camera interp location, but now we're calling this function, which uses a switch statement based on our item type. If it's a weapon, then we get the first element in the interp locations array on the character. But if it's a ammo type, then we get one of the elements 1 through 6, which has the lowest item count. And also when we start the item curve, we're increasing the item count for that element in the interp locations array. Here's the interp locations array on shooterCharacter.h. So let's go ahead and let this compile and give this a test. All right, we're back in the editor, and to test this out, I'm going to need multiple ammo pickups in the world so we can pick up a lot of them in rapid succession. And hopefully we'll be able to see them interpolating to one of our different locations, one of our 6 interpolation locations. So I've made about, looks like 6 ammo items in the world, and one of the things that I'm going to remove from our character is the meshes. So let's go to character, shooter character BP, and we added these meshes so that we can see the locations of these scene components. But now we don't want to see them when the game's playing. We just use them so we can set up where the locations are. So let's go ahead and remove these. I'm going to go ahead and just take the static mesh and set the static mesh property to default so there's no actual mesh there. I'm going to do that for all of these. I'm just going to hit this curved yellow arrow, and that way, one by one, each of these static meshes will disappear and we won't see them in the game. So we'll go ahead and compile and save that. And now if I hit play and run through these, then it looks like they're not interpolating correctly. So let's go ahead and take a look at what's going on. Okay, after poking around, I discovered that we never set the item type here on ammo 9mm BP. It was set to default max, which was the default value given in the constructor. So we need to set item type equal to ammo, and that way the switch case when getting the interp location will actually trigger the ammo case. So go ahead and select each of these pickups in the world and set their item type to ammo. So if they say default max, we'll need to set them to ammo. And since we set the default on the blueprint to ammo, any other ones that we drag in, such as say dragging one in here, it should have ammo for its item type. Okay, so let's go ahead and hit play and run into all of these ammo pickups. And there we go. They interpolate to the various interp locations. And if we pick up too many, say, let's say we have 12 instead of 6 here, I'm going to select 6 of these and go ahead and duplicate them. Now we have a whole bunch of them. Now if I go ahead and hit play and run into all 12 of these, then we will start to see our algorithm at work. All right, perfect. Now that was a whole bunch of ammo, and we'll probably never run into that much ammo in the game at any given point in time, but the system is now robust enough to handle a whole bunch of different item pickups like this. Now the only thing is, as we run into like 12 item pickups at once, you'll notice that we're bombarded with all those pickup sounds. So what we're going to do in the next video is limit how many sounds can be played at any given point in time, because this is a whole lot of sound bombarding your ears. Okay, so we'll fix that in the next video. For now, great job, and we'll see you in the next video.